Здравствуйте.
Hello. Now I'm a postdoc in information security at St. Petersburg University, and I will be talking about risk assessment and countermeasure selection. There are three stages to that process. That is identification, if you like, benchmarking, based on which you will actually start risk mitigation. Well, a lot has already been researched in this area. We propose a three-step methodology here: identification, analysis based on available protection, and finally mitigation. The key characteristics of this approach include assessment of your assets, events, vulnerabilities, threats. We also use the open standards of the SCA protocol for automated representation of security data. For risk analysis, we also use a multi-layer hierarchical system that would distinguish between different parameters based on the amount of computing power they need for assessment. This approach also enables us to take into account security incidents. Shown here is the SEAMS system that has been developed previously by my lab partners and their European partners. So essentially, our system will collect correlated events from the event analysis subsystem. The objective of this research was to develop, implement, and test risk assessment and countermeasure selection tools. So we wanted to achieve a more adequate assessment of current security profile and better selection of countermeasures in line with existing national standards. Based on the existing standards, one can identify two different risk assessment methodologies, a basic and a detailed one. And they can also be further distinguished into static and dynamic. Well, the basic methodology is exceedingly simple. We will be using CVSS, context assessment, but we also sort of adjust it by asset criticality. And asset criticality will be driven by integrity, confidentiality, and one other factor. So then we have a range of scores from 1 to 10. Shown here is pretty much the same stuff, but in formulas. So we will take away the time parameters from the CVSS formula if they are not used, and instead we will apply our criticality parameters. The detailed methodology is shown here. The detailed methodology is based on the traditional understanding of risk as a multiple of impact and probability. And probability is essentially based on a Bayesian attack graph. Then our algorithm is based on three steps where we will assess the vulnerability of local hosts based on CVSS data. For core nodes of the graph, we'll also look at access vectors. And we can augment this assessment with data on perps, historical data, on successful historical attacks. This will give us conditional probability information and full probability of graph nodes compromise. So for individual subgraphs, probability of compromise will be recalculated together with recalculation of risk. We also take into account data coming from CM systems regarding reliability of the system. Now, if we see a particularly high risk, countermeasure selection algo will kick into action for all the nodes that have a high risk profile. Countermeasures will be shortlisted. If a countermeasure if several countermeasures will be applicable to pretty much the same number of nodes of interest, then we will actually execute several lists, or we'll look at cost-benefit comparison between them in order to select the right list of countermeasures for specific nodes. Shown here is the prototype architecture, so it shows input data, sources of the data, processing components. From there, the data will go into the countermeasure selection component. Now, let me show the product of this research. This is in fact a short, simple example. So here we're assessing a network element or network subsegment on 3 counts, that is confidentiality, criticality, and availability. The initial attack graph is shown here, and shown in green are the nodes characterized by a low level of risk. After we process the incident, she drops the subject. Now, we have developed a sequence of attacks based on CAPAC templates because we simply needed to populate the database, so to speak, and shown in pink is the particular sequence we analyzed. So after we adopted this data, this is how the graph changed. So after security incidents are processed, well, we obviously see that green turns into yellow. Shown in pink are the incidents currently being processed. After the first incident, we will see a substantial number of nodes that have changed their risk profile. After the second incident, we will see a particular node for which the risk profile is different, and this is the big disadvantage of the proposed method. For subnets that have loads of hosts at the same level, we will see those changes in risk levels for numerous hosts at the same time, so it will be very difficult for us to predict the sequence of future steps of the attacker. Now, what can we do here? First, we can add additional data, additional characteristics. For example, the nodes that have changed their risk profile are obviously part of the subset of the nodes that have really been attacked. So we can select countermeasures at the subnet level. Now, shown on top is a sample of data or a sample of countermeasures that will be proposed for the compromised nodes. And shown below are actually the shortlisted countermeasures that have the highest scores, such as temporarily blocking individual nodes. So within our prototype, we implemented several different methods of risk assessment. We tested them, we identified their flaws that we are currently removing, and we'll keep focusing on expanding the functionality of the system. Thank you very much. That's the end of my presentation. Thank you. Any questions, gentlemen? Sorry, but what kind of analysis do you run in order to assess a probability of a particular event? Is that a regression analysis? I'm sorry, I couldn't find you. Well, usually there are two components that you will use for your analysis. That's the criticality of an asset's price of an asset and the probability of a particular event. Well, as regards asset value, now we are talking about business assets, right? For business assets, valuations come from business, so it's easy. Well, after that, we also need to assess the value of the technical assets that sort of support the business assets. So this could be software or hardware. For all of this, we will need to identify vulnerabilities. So essentially, we start with a dollar value, but then we translate it into a criticality score. And then we assess a local probabilities of being attacked based on CVSS index. Hello. It was slide 6, I believe, where you showed a particular assessment scale. Where you assigned 1 to probabilities that you couldn't really verify, and the max level is 1.5. What's the logic for that? This is actually CVSS scale. This is not our sort of scaling, but the logic they have for it is as follows. When CVSS combines data on exploitability and impact, the total, the max you can get is 10. So when they use these numbers in the formula, if you scale it back, if you go from 10 to the individual multipliers, you will get this range of 0.5, 1, and 1.5. Okay, so you're basing it on CVSS, but I'm assuming you could have arbitrarily chosen any other number, right? Okay, thank you. Thank you, Elena. So selection of countermeasures, will it be driven or will it be made from a fixed exhaustive list, or can it be updated? And what about the vulnerability of individual countermeasures? Well, so far, no automated list of countermeasure delivery procedure has been implemented. But we understand there are standards for doing that. There is a SCAT protocol, so I think we can develop a remediation database that could be linked directly to CVE. But currently, we assume that if companies want to use the methodology, they will be using admin pre-approved lists of countermeasures. Last question? Unless this one is very short, then we can entertain another one. Hi. Do I get it correctly that the assessment you make based on attack risk assumes it's not a targeted attack? Because in targeted attacks, attackers usually try to keep a low profile. They are very stealthy, so they will use social engineering, for example, or they will try to exploit low-rank vulnerabilities so that they are not seen. That's right. We are not really taking into account targeted attacks here. But we do take into account the difficulty of accessing a particular vulnerability. So that should sort of partially compensate for it. But CVSS doesn't really reflect this difficulty or complexity. Say in CVSS 3, it's not really reflected. What CVSS looks at is whether all the preconditions for mounting an attack are controllable, so to speak, by the attacker or not. Well, I do agree with that. This will be the last question, gentlemen. Well, indeed, some of the solutions you've been talking about have previously been implemented within the Massive or Air Raid project. And we understand that they've actually been implemented in open source SIEM system called Open World. Now, do you think that there is a demand for this sort of research? Has there been any interest for what you're doing from SIEM developers? Have you tried pitching your methodology to them? Well, obviously, we wouldn't do this research if we thought there would be no demand for it. I'm Igor Kutenko. I did speak in previous PhDs, and I spoke about massive air raid technology. Important thing to remember is that you shouldn't really assess it only at the level of our lab, because we worked with about 12 different partners from different countries. And we're all developing the system in different areas. There are several prototypes of SIM systems developed by a number of organizations. Well, we are developing our prototype, for example, for cyber-physical systems. So if you're interested, we shall be happy to discuss it with you. Thank you.